So this time, for 23, find the area if it exists under the region of the graph. And so we have some function, which is x over e to the x squared. So we want to find everything, area under the curve, to the right of x equals 1. So I could sketch it. That's what the curve looks like. So yeah, maybe type it in. So you have x divided by e to the x, and then it's x squared in the denominator. So graph. And so this is a quarter here, so we're looking at something of this shape. And this actually ends up being cut off around here. So we're trying to find that area, and it's unbounded. But from the graph, you should be able to see that does die off pretty quick to 0. So we're going to see what happens here. But the technique we're going to use is we're going to find the definite integral for this area and then ask what happens as we send b off. So the area under this curve is represented by that. So what's our function? X over e to the x squared dx 1 to infinity. Okay. We have infinity in the bound, again, replacing it with b and then sending it off once we find the finite area. And then we ask what happens when we change the bound and make it bigger. So 1 to b, x over e to the x squared dx. Okay. So you may look at this and wonder what to do here. If you pull this e to the x squared into the numerator, it'll end up working pretty well. So e to the minus x squared, right? We're pulling it up, so we get a minus x squared, and then we have x dx. Still have this stuff here. Okay, to this, we now need to do a u sub. So the u is going to be minus x squared, and then the du, take the derivative of that, so that's minus 2x, and then we need dx. Okay, we know we're going to have u there. That's going to go to u. Question is, do we have our dx, or du? So we have the dx, we have the x, we need minus 2. So we're just going to put that in. So we have negative half times minus 2 cancels to go back. Okay, but now we have the du. So this will end up being e to the u du, and we have u of whatever these bounds are. So u of 1 and u of b, and we still have this limit as b goes to infinity. So after u sub. Okay, the u sub was successful, so that's going to be, oh, wait a minute, drop the minus half, right there. The u sub worked, so we find the antiderivative of that, that's just e to the u, but now we have to plug these in. And we have the minus half here, limit as b goes to infinity. Okay, we're going to go sub back to x. So this is minus half e to the minus x squared, and then from 1 to b, and we still have this limit here. Okay, so plug in. Limit as b goes to infinity of this. So minus half e to the minus b squared minus a half e to the minus 1 squared. Okay. So minus 1, so this is minus 1 squared. So this is 1 squared is 1, and then we have a minus there. So that's positive. So we have 2 e to the minus 1. So this is going to be, this term will be 2 over e. And to that, we're adding whatever this piece does. So again, this part was a constant. This involves our variable. So we're going to have big number squared and then a minus in front. So this will be minus a half e, and then it's to this negative big number. Because you square a big number, you get another big number. But it's important, the minus sign. So e to a minus big number is going to be 0. That's 0. Yeah, so that's 0. So we get 0 times minus a half. So you get 0 plus 2 over e, which gives 2 over e. So this result converges. Okay, just to answer this quick, in case you have a question about it. So e to the minus big number. The graph of e to the x looks like this, and we're evaluating minus big there. So this heads to 0.